What's up guys? In this video we're going to be talking about irrational numbers, real numbers, and estimating roots. Let's do it. So far we've worked with two types of decimal expansions. We have the terminating decimal and we have the repeating decimal. Let's take a look at a couple of examples of each one. But is there any other kind of decimal expansion? Well, take a look at this number, 1.2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We can't imagine that this pattern goes on forever, so this decimal is not terminating. But we can also see that this decimal doesn't repeat. This is a new type of decimal expansion, infinite and non-repeating. We know a couple of methods of turning decimals into fractions, but can we do it here? Why don't you pause the video and give it a try? You might have realized that we can't turn this into a fraction. Keep in mind that all of our fractions, when we turn them into decimals, are either terminating or repeating. So what type of number is this? Well, it's what we call an irrational number, not rational. Some examples of irrational numbers are the square root of 2, pi, the number phi, the number e, and many more. Let's write some of these in our calculator. The calculator gives us very long decimal expansions, but obviously they're not infinite. They couldn't be, because the screen is not infinite, and even if it were, the calculator's memory isn't, and it could never hold such a large number of digits. Let's look at a diagram that shows us the sets of numbers. We begin with the smallest set, the set of natural numbers. Some of the numbers in this set are 0, 1, 2, and square root of 36, because that is equal to 6, and 6 is a natural number. The next set we're going to look at is the set of integers. All of the natural numbers are integers. Some other elements of this set are -2, negative square root of 9 because it is equal to -3, and -10. The next set is the set of rational numbers. Numbers in this set are, for example, 0.5, 0.3 repeating, the fraction 2/3 or 2/3, the square root of 25/16 because when you simplify it, you get 5/4. And now we have a new set that contains the numbers that we just talked about, the irrational numbers. Notice that the irrational numbers don't contain any of the other sets. They're completely separate from the rational numbers. Together, the rational numbers and the irrational numbers make up the set of real numbers. But wait, what is this symbol for irrational number? Well, it's r minus q. Because this set is what is left over from taking away the rational numbers from the real numbers. Okay, so here's a question for you guys. Where does the square root of 16/4 belong? Well, we can simplify this as 4/2 by taking the square root of the top and the bottom. We can simplify it further by dividing the top and the bottom by 2. We see that this number is equal to 2, which belongs in the set of natural numbers.